Yeah, so I'm guessing they didn't do a good job of specifying what the reference point is there, but I'm guessing the reference point is the positive x-axis.
Okay.
Should we just
But-
always assume that?
Usually they do a good job of saying, you know, report the direction in terms of the positive x-axis or above the positive x-axis or something like that.
I've had several questions that didn't happen, so.
Then yeah, I mean the positive x-axis is usually like when we have like our unit circle, if we think back to trig or whatever, that's usually like our 0 mark, and then we start going counterclockwise from that point to get to 90 degrees, 180 degrees, 360 degrees. But yeah, I would like them to be more specific. But yeah, we can assume that for right now, and that's probably a pretty safe assumption.
Okay.
So we are looking for this angle right here. So if this is our x-axis, we want to know how many degrees above that x-axis our vector is.
Okay.
So to do that, we pretty much just do our trig functions that we did earlier, but we kind of work backwards a little bit.
Okay.
So relative to this angle, here is our opposite side, and here's our adjacent side, here's our hypotenuse. We know values for all of those.
So we can just pick whichever one we want.
Yeah, total preference. We can use sine, cosine, or
Why don't we
tangent.
just do sine then?
Okay?
Yeah, I
So
think
that
it's
would be
simple.
opposite, so that would be 11.1 over hypotenuse, so 15.91.
Good. So we have sine of theta equals 11.1 over 15.91. That's just a number that we can punch into our calculator.
We can do like the inverse.
Good. So that's what I was talking about when I said it's kind of the same, but we have to work backwards a little bit. So now we use the inverse function instead of just the regular sine function of whatever that fraction ends up being.
Okay, that's what I was gonna ask. Do we just punch it in as?
Yeah, you
We-
can solve
we
this
do
part
s-
first if you
We do
want.
sine of 11.1 over 15.91,
Mm-hmm.
and then
Yeah.
the answer to that is what we put inverse sine.
Oh,
Well, you can either divide this out and then do the inverse sine function to whatever that number that gives you, or you can just do the inverse sine function of this fraction. Either way.
Oh, either way will work.
Mhm.
Oh,
just
that's
make
good.
sure that you're using like parentheses.
And also make sure that your calculator's
Yeah.
in degrees.
Yeah,
Oh yeah,
I haven't used radians.
I probably
That's
should
true.
get a calculator.
Yeah, feel free to use this one. It's in degrees right now if you want.
Okay, thanks.
If you want practice.
Let's see. Oh yeah, I have to type it in first with this on.
Yeah, I guess that would be the same thing.
I'm not really used to this type.
7.
Yeah, it's kind of
I have a
a
different
less
type.
intuitive calculator. So you don't have to use it if you don't want to. It is foreign, I'm sure.
I have like the one like that one, but bigger. Oh, well, not bigger, but I don't know where it is. So.
Yeah. Calculators are one of those things that just always go missing.
I know.
So I got 44.2. Is that what you got, Jason?
No, okay.
What did you get?
I got 69. Well, no, actually, I
So
did
let's-
something wrong.
Let's take a look at what you did.
I'm probably just messing up.
So
Let me redo it. Okay, so
11.1.
Sine 11.1.
We're not taking the sign yet. So just,
Oh, that's what I did wrong then. So just punch in the fraction itself. 11.1 divided by
15.91.
15.91.
And then take the inverse sine of that.
Gotcha. I'm sorry, I was missing that last step.
Or if you'd rather,
Perfect,
you can
okay.
just start with the inverse sine and then in the parentheses just put 11.1 divided 15.91
So it goes 1.1.
and then close the parentheses and then hit enter.
Huh.
So same thing either way, whatever, you know, clicks best for your mind.
Okay.
Okay.
Any questions there? Not too bad. And then be careful with sig figs again, because I know that that program is really picky about.
So the nearest tenth of a degree, so it would be 44.2, right?
Yep, that's what I got.
And how do we know if it's negative or positive?
So in this case, Since it was above
Oh,
the
yeah.
x-axis, it would be positive.
Okay.
If we had had a vector that was pointing down and to the right, then it would have been negative.
Okay.
We could even report this one as a negative if we wanted to. If we wanted to start here at the x-axis and go around this way, then it would have been a negative number, and it would have been some big number, you know, close to 360.
Yeah.
Does that make sense?
So either one, it's just a different way of writing it.
Yeah, it's just if you start going clockwise or if you start going counterclockwise from your reference point. So the
Okay.
x-axis is our reference point. So usually you go whichever direction is going to get you there faster,
Right. Okay.
which in this case is the counterclockwise direction.